This is part 2 of the first set of notes that goes along with what is science and parts of the experiments. Towards the bottom then of the first page, a series of planned steps that's used to solve a problem is called the scientific method. You use the scientific method every day of your life, whether you realize it or not. We are going to break it down into 6 formal steps. As far as conducting a lab experiment, you're going to need to follow basically these 6 steps in completing a lab. So step 1 in the scientific method, you should always state your problem, which is partially about asking a question. What are you trying to solve for? Well, by knowing what your problem is, that gives you a good start as to where you need to go. Now, typically, step 2 is you're going to gather some information. We're going to do some research. Now, for the labs that we're going to do, I am normally going to provide that extra bit of information that you may need. But if you're conducting an experiment from scratch, that's where you're going to go to the library or go to the internet and do some research on your own. So step 1, state the problem. Step 2, you're going to gather information or research. Step 3 then is where you're going to form your hypothesis, hypothesis. Your hypothesis is your educated guess. This is where you're going to make your assumption, make your guess as to what you think the answer may be whenever you attempt your experiment. Part 4 then, step 4, is your actual test, your investigation. Here is where you're going to conduct your experiments. Step 5 then, you're going to analyze the results of your experiments, whatever you got. Analyze, A-N-A-L-Y-Z-E. Analyzing the results. Typically, you're going to have some sort of data table, chart that you're going to look at and compare your information with the different things that you're testing for. And step 6, you're going to draw your conclusions then. Was your hypothesis right or wrong? If you were wrong, maybe you're going to go back and try the experiment again. Figure out what happened with it. Whenever you do conduct an experiment, realize there are certain parts of an experiment that always must be there. The variable, V-A-R-I-A-B-L-E, the variable is that factor of an experiment that changes. It's what is being tested. A good experiment should only have one testable variable. We're going to see what that one testable variable is. We're going to break it down a little bit further. Now, in an experiment, part B, you can have many, many constants. C-O-N-S-T-A-N-T-S. Constants are those factors that don't change in experiments. A good experiment can have many, many constants. When you come back to school, your 2 days that you're with me, we're obviously going to use these different terms to actually do some experimenting with, and you can see what the differences between these. A good experiment should also have a control group. Control, is the standard of comparison. It's normally that thing that you set aside, you don't do anything to it, you leave it alone, and when you conduct your experiment, you have your experimental parts to compare back to that original control group. Now, as I stated before, variables can be broken down into a couple different types. The independent variable, independent, I-N-D-E-P-E-N-D-E-N-T, is that factor that you change. It's what is being tested. It's the testable factor. So when we do our class examples, we're going to focus mostly on the independent variable. Now, the dependent variable, D-E-P-E-N-D-E-N-T, is that factor that doesn't change. Well, I'm sorry, it changes, but it changes as a result of the independent variable. The dependent depends on the independent. Imagine that. That's where the term comes from. And finally, whenever you're a scientist and you're conducting experiments, one thing that your experimentation will lead to possibly is theories and laws. A theory, T-H-E-O-R-Y, is an explanation that's based on observation, investigation, and fact. There are some pretty famous theories that are out there. Big Bang Theory, theory of continental drift, many, many others. I don't care if you write down one example, more examples. We're talking about scientific theories here. There have been theories in the past that have been disproved, basically. Theories that no longer hold weight because as we learned new evidence, those theories basically became obsolete and they weren't accepted anymore. A scientific law is a rule of nature. It's something that's true all the time. It's something that never changes. Good example of this is the law of gravity. You know this as, what goes up must come down, but we're going to learn gravitational pull or force, something that deals with Newton's laws and something that's actually calculable. There are gas laws, Boyle's law, Charles' law, that are gas laws. There are other scientific laws as well. So that completes both parts of the two sets of notes then. Again, you want to print this off if you didn't, if you were absent and you needed to print it. Hopefully you got it for me in the classroom though, and you can just clip that into your science notebook, and it's something that we're going to be using in class.